If we buy a bond at less than face value, we're going to have to amortize that discount, the difference between what we paid and the face value, over the remaining life of the bond. This is particularly true if it's available for sale security or a held to maturity security. There are some companies that say if it's a trading security, we're going to buy and sell that thing within a few days anyway, so it's a waste of time to amortize the discount. So let's look at an example of straight line amortization of that discount versus an effective interest rate amortization of the discount in the situation where we have an available for sale security. Both are trying to do the same thing. In both instances, we're trying to get the discounted carrying value, if you will, up to the face value. So whether we're using the straight line method or the effective interest rate method, we're going to take a bond from the discounted price up to its face value at maturity. All right, let's assume we buy a $1,000 corporate bond out there. It has a contract rate, in other words, a face amount of 8%. That means we're going to receive $40 every 6 months. 8% times $1,000 face is $80. Divide that by 2 because bonds pay interest twice a year, and we're going to get $40 every 6 months. Let's assume interest rates have gone up. And why would our required interest rate go up for this bond? Well, maybe interest rates in general have gone up, or maybe the credit rating of this company has gone down, and so there's more risk. So let's pretend like we require a 10% return to buy this bond. How much should we pay? Well, let's go to our financial calculator. Let's clear everything that's in the third row. We're in the third row, we're in the third row, we're in the third row, and I have this trick where I plug in the numbers first as if the contract rate, the 8%, were the same as the market rate. So we're going to get $1,000 at the end. I know that because it's right in here. We're going to get $40 every 6 months. I know that because it's written here. And it's going to be 6 periods. And the interest rate, like I say, let's pretend like the market rate and the required rate are exactly the same. Put in 4% interest. Then we compute PV and we get $1,000, which is the face value. So now I know that I've got the right N, I've got the right I, I've got the right payment, I've got the right future value. So let's just fool around with the interest rate and change it. So we require a 10% return per year. That's 5% every 6 months. So we had 5I, then compute PV, and we learn that we should pay $949.24 to buy this bond. $1,000 minus $949.24 is $50.76 worth of discount. So we actually should also include brokerage fees, but this stuff is already complicated enough. So let's pretend like my brother-in-law sold me the bond and he didn't charge me any brokerage fees. So under the straight line method, it's really simple. We'll take that $50.76 discount, divide it by 6 because there's 6 interest payments between now and maturity of the bond. And that means we're going to amortize it $8.46 every time we receive an interest payment. So every time we get a cash payment of $40, we're going to debit cash for $40. We're going to debit debt investments available for sale for $8.46. And to make that journal entry balance, we'll need to have interest revenue of $48.46. And it kind of makes sense that our interest revenue on our books would be more than the $40 cash, because we only paid $949.24 for this bond, but we're still getting paid interest at 8% per year on a $1,000 bond. So we bought this thing on sale, and we get the benefit of that sale price every 6 months when we book a little bit more interest expense. In this column is the carrying value of the bonds. As you can see, it goes from the $949.24 up by $846 every 6 months till we get to the $1,000. So the straight line method is super easy to calculate, and GAAP won't let us use it. If there's a material difference between the straight line method and the effective interest rate method, we have to use the effective interest rate method. GAAP says that it produces a periodic interest expense equal to a constant percentage of the carrying value of the bonds. And so it says it matches expenses and revenues better than the straight line method. Yeah. But we're still going to go from the same thing. We're still going to go from $949.24 up to $1,000. We're just going to go at a little different pace. we're going to take the effective rate times the carrying value of the bonds minus the contract rate times the face value, and that's going to give us the amount of the amortization. I, for the life of me, cannot remember that formula, but I can remember that a journal entry is supposed to balance. So here's the carrying value of the bonds, or the book value of the bonds at the beginning of the period. This $47.46 is the 0.05, that's the effective rate per 6 months, times the carrying value, so that gives us $47.46 worth of interest revenue. I know I'm getting a check for 40 bucks, debit cash for 40, credit interest revenue for $47.46. To make that journal entry balance, I have to have a debit of $7.46 to debt investments available for sale. 6 months go by, now the carrying value of the bonds at the beginning of the period is the $949.24 plus the $7.46, gives me a total of $956.70. So the interest revenue for this 6-month period is 0.05 times 956.7, which gives me $47.84. I know I'm getting cash of 40, so to make this journal entry balance, I have to debit debt investments available for sale for $7.84. Another 6 months goes by. The carrying value of the bonds at the beginning of the 6-month period is the carrying value from before plus the $7.84 we added. Means that the carrying value of the bonds is now $964.54. 5% times that gives me the $48.23. I know I'm getting 40 bucks in cash, so to make this journal entry balance, I have to debit debt investments available for sale for $8.23. So we're actually doing exactly what that formula says. We're taking the effective interest rate times the carrying value of the bonds minus the contract rate times the face amount of the bonds to give us the amount of amortization. And we keep doing that pattern all the way through, and sure enough, we end up at $1,000 face value of the bonds and $1,000 carrying value of the bonds. Or if you like T accounts, and for God's sake, who doesn't love T accounts, we do the same thing as we did in the straight line method. We just go at a different pace. $949.24 plus the amortization of the discount, we end up at $1,000. So the difference between the two methods is the straight line takes the total discount, divides it by the number of interest payments, and then debits the debt investments available for sale or held to maturity for that amount every time there's a payment of interest. The effective interest rate method is a little bit more complicated. You take the effective rate times the carrying value of the bonds. You subtract from that the contract rate times the face value. By the way, this is the cash payment that you're going to get. And you end up with the amount of amortization. Both end up in the same place. Both get you from the original discounted amount up to the face value. So don't forget, GAAP says if there's a material difference between the straight line method and the effective interest rate method, we have to use the effective interest rate method. Don't forget that if it's a trading bond, that you might not even bother with the discount or amortizing it because you're just buying and selling that bond within a few days. But certainly if it's available for sale or if it's a held to maturity bond, you're going to have to do some amortizing. But now you know how to do it. I hope that helps.